So basically, if you want to look, I'm on page 260. The first thing we're going to look at is using symbols. We're going to cover a lot of ground today, but again, this should all be review, and hopefully we're already pretty good at it. So sometimes we math teachers have it in our head that everybody knows this because maybe we didn't struggle with it. But I definitely see students struggling with this symbol. And if you had Mrs. Dewar in 3rd grade, which I know you didn't because I did, then you would have learned the lesson that the alligator eats the bigger number. And if you can keep that straight, you've got this licked. So if I said -4 and I want you to compare that to 3, which one's the bigger number? The 3, right? Yeah. So negatives are always smaller than positives. Which one's bigger here? Yeah, -1. I'd rather have to owe you $1 than owe you $5. That's kind of how I think of that one. And this isn't supposed to be, I'm just putting there as a space. There is certainly less than or equal to and greater than or equal to, but we're not going to be looking at those two today. Gosh, let me see. Can I toss you up on one? I don't think so. -3 or 0? 0, yeah. Okay. So, checkpoint. Let's see. 6 and -7. -8 and -1. -25 and -2. And I think that's good. Can you fill in those for those spaces? So, let's see, I'm hoping you have something that looks like this. Thank you. Yes? So, if you struggle with that idea, by all means, ask me. I think I'm gonna go with that and move on here. The next one is absolute value. Absolute value is a pretty important idea. When I was a kid and I learned this, I remember learning this in my algebra class, and my teacher simply said that anything that was inside the absolute value bars comes out as a positive. And at least that's all I remember of the lesson. But he wasn't the world's best teacher, so I think he didn't really get the point of absolute value across to me. Absolute value refers to distance on a number line. So for example, if I have, and in this case, sorry, I should have wrote distance from 0 on a number line. Let's say I have 5 and I have negative 5. The idea of absolute value is that both of these, negative 5 and 5, are 5 spaces away from 0. Direction isn't important. It's how many spaces. And if you think about it, that kind of makes sense. So we don't say that Cuna is, oh, I don't know, negative 12 miles, and McCall's positive 90 miles, right? We don't do that. It doesn't really make sense. We do put direction to it, of course, south and north perhaps, but we don't call one negative and one positive. The other thing, have you ever seen Ferris Bueller's Day Off? If you haven't, you must see Ferris Bueller's Day Off. It's required watching for this class. Okay, I know you're going to say we should watch it in class. Of course we should. I don't know if we'll have time, but that'd be pretty cool. So in Ferris Bueller's Day Off, if you haven't seen it, these two guys ditch school, ditch high school. They steal one of the dad's Ferraris. It's an old Ferrari worth tons of money. They take it into Chicago. They have a good day in Chicago, and they come back, and this Ferrari that had, I don't know, 100 miles on it now has like 400 miles on it. And so Ferris, one of the two boys, says, "That's all right. We'll just jack it up and run it in reverse, and that'll take the miles off." In the yeah, anyway, you got to watch the story. Why does it have that many miles? So, anyhow, they jack the car up, and they've got like a brick on the gas pedal, and it's spinning, tires in the air, and the odometer's not counting at all, which is actually incorrect. If you put your car into reverse and drive it for a little while, you'll notice that it's counting the mileage just as if you were going forward. So, but in the movie, the odometer isn't moving at all. So they're like, "It isn't working. What are we going to do?" And anyhow, but the point is that even Ferraris know that distance is never negative. You can't jack a car up, put it into reverse, and expect mileage to come off. So if anybody's ever tried that, it's been a failure for you, I'm sure. So absolute value, we use bars, just a couple of bars. They're like parentheses or brackets in a way, but you can't get rid of them like you can with other stuff. So if I said, what's the absolute value of negative 3? What this is really asking is, how far away from 0 is negative 3 on the number line? 3, right? So what my teacher said is anything inside the bars comes out as a positive is true. He's not wrong. He just never really explained why. So the absolute value of 5, 5. What if I do something like this? Yeah, that's a negative 7 because the negative is not inside the absolute value. So once the absolute value is evaluated, then we put the negative on there after. You can still have a negative result if the negative's outside. So, how about a check? So pretty basic absolute value problems. first one? 8. Okay. Thank you. Second? 6. Third? -8. Good. All right. Adding integers. So, fair bit of notes today, but it's all, like I said, it's all pretty simple and basic. However, adding, subtracting, multiplying, dividing integers is something that we all make mistakes on every now and then, right? Those signs goof us up. And some people really struggle with integers in general. However, until recently, I've never had a student not be able to answer an integer question if I frame it from the point of view of money. Until recently. What's changed? Any ideas? People don't use money anymore. They use what? They use cards, right? Yeah. So our money system is changing. Anyhow, if we see a problem like -50 plus a -10, we want to combine the terms, and I like to think of this either in terms of money or in terms of a number line. So if it's negative, you're going left on the number line. What have you got?
Uh-oh. Well, I don't have it for this class.
No?
Mm-mm.
Uh-oh.
ID check. 3 criteria. Must be worn, and a lot of you are doing it right. Beat the others up. Must be worn. Visible. At all times.
Oh, man.
3 classrooms down. Yesterday it took me 15 classrooms to find it.
All right, let me know how it goes today. It is what it is. At least we had a shot at the donuts, right? Just a heads up. He's probably going to swing into this class when he does do that. Just simply because, well, he likes me, I think. Sometimes he brings me donuts when I don't necessarily need them. Sometimes I bring him a donut or two. Anyway, so in both cases I'm moving left on the number line. If both numbers are the same, or both signs are the same, this is going to be an addition problem. So I'm going to add the 50 and the 10, but I'm going to keep that common sign. -60 is the answer. Can anybody think of another way that this could be written and yet be the same problem? Yeah, right. Yeah, -50 minus 10 is the same thing. Yeah, this would also equal -60. And since there are different ways to write it, I've seen students go from that to this because they just like that plus in there. So if the signs are common, we add. But if the signs are different, we subtract. So this is going to be 50 minus 10. And I keep the sign of the number that's farthest away on the number line. Kind of like almost an absolute value idea. So I'm going to subtract these guys when the signs are opposite. I'm going to add them when the signs are the same. Okay. And keep the sign of the absolute value of largest number. Since the 50 was positive, the answer will be positive. All right. Good? Yeah. Let's, gosh, is there a checkpoint for that? Where's the checkpoint? That's funny. I don't see a checkpoint there. So subtraction. It follows the same guidelines. Where we run into subtraction of integer issues is when we have something like this. When we have a double negative, when I say double negative, I mean two negatives on the same integer. That changes sign to positive. And that's kind of a little freaky. I'll phrase it a couple of different ways, but this is going to be 28 as an answer. If I'm saying 17 minus a negative 11, a way I've heard this referred to as we're taking away negative. That's kind of an elementary idea maybe here. We're taking away negative. So what do we have if we're taking away negatives? Yeah, it becomes positive. Taking away negative, that gives us a positive. But I think a more mathematical way to think of this is this. What is this negative doing? That's correct. So another way to think of this is 17 minus 1 times a negative 11. Because we can put ones almost anywhere in math, and everything's being multiplied by 1. We just don't write it because that would take up a lot of ink and a lot of extra time. But when I have this negative here, I can think of this as a negative and another negative, and we haven't talked about it yet, but I bet we all know what's a negative times a negative? Positive, right. So multiplying negative times a negative, which is a positive. Okay. How about this? Aaron? What do I need to do here? Okay. So change the signs, yeah? Yeah. Okay. But I'm adding 5 to a negative number. Is that going to add or subtract? Right. Because now the signs are opposites. Once the signs are opposites, we subtract. So that's going to be 18 minus 5, which is going to be 13. But is it a positive 13 or a negative 13? Negative, right. Because 18 is more spaces away from 0 than 5. Yeah. Yeah. So even though I subtracted the 5, it says adding. And that's where the confusion kind of comes into play, I think, on that stuff. You could. You could. You can rewrite that, sure. You could certainly do that. That's at the commutative property, I think, where you can swap them around. Yeah. I've never been big on remembering those properties, but or which one goes. I remember what they are. I just don't remember which one's called which. Um, so check. How about 30 minus a -7, -14 minus a -10, and -14 minus 10. What did you get? 37. And maybe -4. Both signs are the same on the bottom one. What do I have to do with that? Add them, put them together, right. How'd you do? Let's let's have you work on problems. What do I have? 13 up to 42. Let's have you work these two.